Okay, Bismillah ar-Rahman. So we stopped here last time. We started talking about some of the important features that need to be supported by the networking architecture in order to make it scalable and expand it efficiently. So we talked about fault tolerance. We said that fault tolerance talks about the fact that if there is a fault inside the network, whether it's one of the cables, one of the network devices is down, then our network should tolerate that and should still preserve the service while this fault is happening. And then we talked about scalability, and we said that scalability is the ability to expand the network without affecting the performance of the existing users. And today, inshallah, we're going to talk about quality of service and security. So, regarding fault tolerance, networks are divided into two major categories. When it comes to how you establish the end-to-end communication. So you have the communication between two end devices like this, and you want to establish the communication between them using the network in the middle. So one way to do that is to use what we call circuit switched network, in which case each of the initiator of the communication, for example this device, will have to send a request to the network, and the network has to establish an end-to-end physical path between the source and the destination before the communication happens. So we call that switched circuit switched network, which means that we have to establish a circuit, and this circuit will be dedicated for this communication throughout the whole time. Okay. So why we're talking about that, because this affects the way that we do fault tolerance. Because if we have a circuit that's dedicated for this communication, for example, the landlines, the old landlines, they work this way. They use circuit switched communication. So when you start calling someone, what you are actually doing is that you are sending a request to the network to establish this circuit for you. When you do that, the network will dedicate some switches across the whole path that will be dedicated for your call. And of course, this is good and bad. It's good in the sense that when you establish this communication end-to-end, the performance of the communication or the information being exchanged back and forth will be deterministic, will be because you have a dedicated, it's like you have a dedicated pipe. So anything going in this pipe will reach to the other end in a deterministic way, which means in a specific time, in order, and everything will be smooth. The bad thing about this is actually two things. One is that this circuit will be dedicated for your call, which means that the system will have a limited capacity in terms of the number of end-to-end communications that it can support. Right? Because for each call you have to dedicate certain circuits. The other thing is fault tolerance. So fault tolerance in circuit switched network is a little bit tricky, because once one of the cables or one of these switches go down, the whole communication is disconnected. Because this circuit is established. You have to spend some time on establishing another circuit which does not involve the switch that is down. We see the difference? So for circuit switched, you have to spend some time on establishing the circuit first, and then the circuit will be dedicated throughout the call. So if there is any problem in this path, okay, then you're stuck. You have to establish another way. It's like you are going from your home to QU every day through the same path. Every day you're going through the same path. Your memory does not remember anything but this road. So once you see the road blocked, what do? Well, yeah, sometimes you have to go back and you have to check Google Maps and stuff in order to see if there is any other way that will let you through that does not involve this path. Right? So that will take time. So that recovering from faults will take a significant amount of time in that case. Okay? The other thing is that because this circuit is fully dedicated for this call, this will make it a problem because in the past, in landlines, maybe you didn't live these days, but sometimes you try to call someone, you dial the number, and it tells you all circuits are busy now. Why? Because we established so many circuits and it's busy, and so many people are talking to each other, and the system cannot handle this capacity. So when we get to the other type of network, which is packet switch networks. For packet switch networks, we do not establish any end-to-end circuit. The information between the source and the destination will be divided into packets or smaller messages, and each message can take a certain path. So we do not have a dedicated circuit in that case. Some packets can go this way, some packets can go this way, some packets can go this way. So we don't have an end-to-end circuit that gets established throughout the code. So in which case, if one of the routers is down, the effect will be on one or two of the packets that go this way, which means that these packets will be lost, but the call is still on. And I can recover this easily, right? So I can retransmit these packets only through some other path, because I do not have a dedicated circuit. So fault tolerance in packet switch networks is rather simpler compared to, in packet switch networks is rather simpler compared to circuit switch networks. Okay? So this is the type of network that we use nowadays in 99% of the time. So still, landlines still use the circuit switch networks. Some other types of networks which have become really obsolete, that they still use the circuit switch networks, but most of the networks that we use nowadays, they somehow use packet switch networks. Okay? So in terms of capacity, the packet switch networks is more efficient because I do not have to establish a dedicated circuit. So many users, they can use or they can share any of these links at any point in time through what we call multiplexing of these packets or interleaving of these packets. We'll talk about that in next chapter. So this makes the capacity of the network overall more. Okay? Even though you're still using the same physical resources, but the way that you assign these resources to the users here is more efficient. It's per packet as opposed to per call. Okay? So it's like higher granularity. Okay? So fault tolerance is a feature that we can support on all types of networks, but as we have mentioned now, is that for circuit switch, it's a little bit tricky. Scalability is also another issue on the internet that has to be supported, and for that, we have the concept of hierarchical internet service provisioning. So what does that mean? This means that the internet is divided into tiers. So we call it hierarchical architecture. Okay? And by tiers, we mean like there is a tier 1 service provider, which gives service to a tier 2 service provider, which gives service to service providers like local service providers like QU, for example, and then eventually to users. So this makes the architecture is scalable in the sense that if you need, so the tier 1 service provider usually has very, very extremely sophisticated infrastructure that allows them to support multiple tier 2 service providers. So tier 1 service providers, there are very few service providers on the internet that is tier 1, like AT&T, Verizon, most of them are in the States. And these, like, sort of, they have huge infrastructure, very sophisticated, very high, very like heavy duty, and of course, all based on like sophisticated like fiber optics and things like that, which can carry huge amount of traffic. Tier 2 service providers like Ooredoo, like Vodafone, all these service providers, and they usually have still huge infrastructure, but it's not as sophisticated as tier 1. And they they take the service from tier 1 service providers and they offer this service to local service providers or to users. Okay? Then local service providers like QU is considered a local service provider which provides this service to students and to faculty members and to different users. Okay? So this hierarchical architecture makes the architecture overall as scalable as possible. Okay? So if you want to expand the network, you have to if you want to expand the network of QU, for example, so then you have to add more switches, you have to add more routers in order to expand the network without affecting the performance of the existing user. But if you want to expand the number of users of QU very large, then you have to talk to Ooredoo and possibly get higher speed connection from Ooredoo. Ooredoo will then, keep that in mind that the amount of traffic overall does not exceed the capacity of Ooredoo. Otherwise, they will reject your request for expansion. So scalability means that we have to expand the network, keeping in mind the performance of the existing user, but it's not unlimited. So we cannot really expand the number of users on the internet in an unlimited way without really paying much attention to the performance of the overall network. So each of these service providers, they have some assessment for their capacity, and based on that, they can accept or reject certain requests. But the fact that most of these networks nowadays is based on packet switch networks, this makes the capacity of these networks more efficient compared to circuit switched. So packet switched makes the network usually more scalable compared to circuit switched. So for circuit switched, if you want to expand the number of users, you always have to add many switches in order to increase the capacity. But for packet switched networks, if you replace one of the routers to high-speed routers, then the capacity of the system will be pumped up, will increase, without having to increase more routers in the network. So it's more scalable in the sense of how you assign resources to the users, because you do not have to establish this physical circuit end-to-end. Again, all these concepts we will revisit later on. We will talk about them more, and when we talk about protocols and details, this will become clearer and clearer. Okay. Quality of service. As we said, quality of service is all about discrimination. So we want to discriminate between the users in such a way that allows the network to provide different types of services to different users based on their demand. Okay? So we have some users with demands like they want 10 megabits per second. We have other users with like 1 megabits per second. So the more you pay, the more you get higher quality of service. But this has some implication in terms of how we design the network. Our routers need to discriminate between the different traffic. So the routers need to be smart. It's not that we give these plans to users and we don't do anything special in the network. So we have to make our routers smart enough to be able to distinguish. This user paid more, so I have to give him more resources. And with packet switched networks, this is possible. More than circuit switched networks. With packet switched networks, it's possible because the resources can be assigned to the users on a very high granularity, on the packet limit. So I can really maneuver my capacity based on the demand of the user and based on how much he paid. So I can give to each user different quality of service. So for example, this user requires video traffic more. So I can give him resources from the network in such a way that gives this user very low delay, okay? And maybe some packet loss, there's no problem, because as we said, video is very tolerable in terms of packet loss, but it's not tolerable in terms of delay. Okay, so we mentioned the example of YouTube. that on YouTube, if you have a small delay, then this will cause some pauses in the video, and that usually makes you as a user frustrated. So this is not a good quality. But if you have some packet loss, some pixels are lost here and there, you won't even notice it. Okay? So unlike that, there is like web browsing. If the web page gets delayed, that's fine as long as you get the whole web page without any packet loss. So so different types of applications, different requirements from different users will imply different quality of service in terms of delay, packet loss, and so on. And the network has to tailor its capacity to meet each of these requirements from different users. Okay, so time-sensitive communication versus non-time-sensitive communication, whether it's packet loss is tolerable, not tolerable, and stuff. That's what we mean by providing different quality of service. Of course, security is a big deal in all countries all over the world now, and especially in the region, especially in Qatar now, and it's becoming more and more critical. So security talks about securing our information. So we have to secure our information, which means that whenever we store the information, it has to be secure. We have to make sure that whoever is accessing this information is really an authentic person, and he's really the person that he says he is. Okay, so we need to have authentication and so on to make sure that the users who access the information are eligible to access this type of information. That's on the information security side. But also on the network security. Network security is a big deal. Why? Because we have to secure our network devices, which means routers, switches, and these things. Why? Because imagine if one of the routers is hacked. This means that our information can get somewhere that's not supposed to happen. So if some of our routers and switches are hacked, this will cause a great disruption to the traffic. So many of the packets may get lost, in which case you will never have any efficient communication. So security can be divided in multiple domains and multiple levels. There is information security, there is network security, and so on. Okay? So security is a very big issue, and we have to address the issue of security in different levels of communication. In storing the information, in communicating the information, securing the network devices, and so on. Okay? So there are some trends on the internet that are becoming feasible and more attractive now to people. So there is the concept of bring your own device, which we will talk about. There is a concept of online collaboration, which includes all types of collaboration software, including Facebook, including all the software that we use nowadays. Video is a big issue that's becoming more and more critical and more important to be supported. And there is the concept of cloud computing. Of course, most of these trends are new, and we did not address any of these trends in previous version of CCNA 1 because they are recent applications. So there is the concept of bring your own device. What does that mean? This means that our applications need to tailor to the device that we use. So the same application needs to be customizable and needs to be flexible in the type of device that we use. So we see, for example, when you log on to MyQU, if you log on your laptop, you get an interface. If you log on your cell phone, now you get a totally different interface. And this interface is really suitable for the type of device that you use. We didn't have this concept a while back. So it's like the web browser would be fixed, the interface would be fixed for whatever device you use. And that sometimes creates some bad user experience. Okay? So when you see the same interface on a very small screen, your experience would not be that good. But there is now the concept of bring your own device. Whatever device you use, will tailor our application and our interface based on the characteristics of your device. So our application will be flexible to run on any type of device. Okay? So you can have any content, and the content should be malleable, should be flexible enough to get displayed on the different types of devices in a totally different way, which would give you good experience on each type of device. Of course, online collaboration is becoming more and more evident these days. In the past, we used to use like only messaging and these kind of things. So now it's becoming more and more sophisticated. So now we have Twitter, we have Facebook, we have telepresence, we have all these types of online collaboration, which makes the communication between people very seamless and in some cases like very real. Okay, and there is some diversity when it comes to online collaboration tools that we use on a daily basis now, whether it's WhatsApp, voice calls, and things like this. That makes this this concept really more evident in the internet. Video is, people have been calling the video as the killer application. The killer application. In the past 2 decades, we used to call video the killer application. What does that mean? This means that video traffic is always the dominating traffic on the internet. So if you were to get to the core of the internet and get all the traffic that we send, okay, and classify this based on the type of traffic, you will find that video always consumes, on the average, around 80% of the internet traffic. So there is always a big challenge on the amount of video that you can support over the internet. And now we have high definition TV, we have 4K monitors that requires extremely high quality on the screen, and our demands in terms of video is increasing day by day, and that makes video really a very critical type of traffic that we need to tailor our network to be able to support video in an efficient way. In other words, no matter how much capacity you increase in the network, video is always increasing in terms of the quality, in terms of high definition and stuff, which absorbs this bandwidth. That's why they call it a killer application. It kills the bandwidth of the internet. Okay? So video is very critical in that regard. Cloud computing is a very interesting trend that only appeared in the last decade. And this concept has been initiated by the fact that some people have invented like a virtualization layer that connects all your resources as one unit, which means that you can have millions of old machines, okay, connect them through a network and have some virtualization layer, and all of a sudden these old machines will become one huge, humongous machine. And you can deal with these millions of machines as one huge, humongous machine with great capacity and huge amount of resources, even though each of them is very old and it's not even usable. Okay? So cloud computing talks about the fact that now our infrastructure in terms of storing information, in terms of network platform, in terms of anything, can virtually expand and become like one unit for the user, and the user can connect multiple unusable machines into one huge machine that can have huge amount of resources for people to use. So for example, Amazon, they have a cloud facility that includes millions and millions of machines across the world for not only about hosting information, hosting applications, hosting video, hosting whatever you want. Okay? So we talked about storage area network when we said that storage area network makes virtually multiple machines to be like one big storage capacity. Cloud computing is a general concept which applies the same idea for different domains, like for storing information, for running applications, for video, for TV channels, for anything. So in general, computing facilities. So computing facilities can virtually expand and become huge. And these computing facilities can be used for storage, can be used for application processing, can be used for anything. So there is a cloud computing talks about a complete isolation between the hardware and the software that is running on top. Okay? So the hardware is like millions of like, for example, millions of small hard disks. Each one of them is 1 meg. Okay? So cloud computing talks about the fact that all these millions of 1 meg devices will virtually be one huge hard disk. It's one unit. You see it as one unit of like 100 gigabytes or like 1 terabytes. So the user, when the user tries to use these resources, the user will see virtually 1 terabyte device. But in fact, this 1 terabyte device is divided into million of 1 mega device hard disk. You don't see the physical resource. You see only a virtual resource that you can use. And you deal with all these physical devices as one unit. You don't care where your information is stored. So this way, this is a very important concept in the fact that I can offer this storage as a service to users, okay? And then based on your demand, you can enter the system and say, I want a hard disk of 5 gigabytes, for example. So the system will virtually connect 500 devices to you and give this to you as one machine. Okay? You don't care, right? So I need to build a machine with this requirement. 500 gigabyte of hard disk, 4 gigabyte of memory, this much speed, and so on. Okay, the cloud facility will connect some physical resources in order to create a virtual machine with the characteristics that you asked for. And the good thing is that this machine can be built and then destroyed in no time. See how beautiful this concept is? So you can build any machine with any requirement to use it for a particular amount of time and then kill it after you finish. It's really a beautiful concept in the sense that you can use all your physical resources in a very customizable way and based on the user requirement. This same concept applies now to all types of computing domains that we study or we talk about. So whether for storing information, for processing, so again, for processing, I have millions of CPUs. I can aggregate these CPUs to the user. If the user wants 3.5 i7 whatever processor with a specific amount of processing capacity, I will connect some physical CPUs to the user seamlessly. The user doesn't even care what is the physical resources are. He just needs to see one CPU with this speed. I will give him this one CPU with one speed. Okay, so everything is becoming virtual. Okay, so there is a great separation between physical resources and virtual resources that we can use. And the good thing about virtual resources is that we can create it whenever we need, with any characteristic we want, and once we finish using that, and we want another machine with another characteristic, just destroy this one and create another one.
Can you give us another example, please?
So that's what I'm saying. So YouTube uses some kind of cloud facility. All the big companies now, they use cloud facility one way or another. So so YouTube for you is just a big cloud. Whenever you push or upload any video, it gets automatically pushed to one of their physical servers. But for you, you just see YouTube, right? In a way, it could be. I don't know. Like maybe QU here, they use data centers, and data centers they are very huge hardware. Maybe that's divided into physical, smaller hardware. Each of them they have small storage capacity with small processing capability and so on, and based on the amount of space that you want, based on the processing speed that you want, you can create a virtual machine, okay, to store the emails on the QU server. The good thing is that after some time, well, now you have, مثلا, you have 10,000 students. So you do your assessment and you say, okay, I need this amount of storage, I need this amount of processing, I need this and that, okay? So you create a virtual machine on this data center, on the cloud facility, okay, with these characteristics. All of a sudden, alhamdulillah, now we have 1 million students, okay? So all you need to do is just to say, virtually I need to expand the virtual machine into a huge virtual machine and things like this. So there is a great isolation between the machine that you create and the physical hardware. So now you can, if you need later on, your data center can have more and more resources physically, which allows you to create virtual machines with greater capacity. Okay? So now you can expand the physical resources to allow you to have more and more flexible capacity on the virtual machine that you create. So there is, again, this isolation. Now, I mean, in the traditional type is that we all have one machine at home, we're stuck. Once it gets old, what do? We throw it away, we bring another one with larger capacity, right? So that's what we do, which is not efficient. So now, with the concept of cloud computing, we can connect these machines using virtualization layer that can aggregate these resources in one unit. So now, instead of having two machines that are not usable, we have one huge machine that's now, usable, and it has more capacity and it has more speed and so on. And this virtualization layer will act as the interface between your application and the physical hardware. For example, your application runs parallel on two different processors. So it's as if you have one processor with double speed. But you don't know. The user doesn't know. Okay, so that's what cloud computing gives you. So with that, you have great advantages. You have great flexibility. So the organization can have a data center and they can expand the physical resources at any point in time. Okay, without affecting the application. They don't have to throw the old hardware anymore. خلاص. Okay, so they want more capacity. They can build virtual machine until they get to the limit of the physical capacity. Now they have to expand the physical resources without throwing the old resources away. So they can expand the hard drive in terms of physical resources, and then you can create a virtual machine that can use these expanded resources. There is agility and rapid deployment. As I said, you don't have to throw anything away, you just need to add. So this concept is good. Because in the past, we used to throw the old hardware, bring new hardware that has more capacity. So now, we just rapid deployment. We just deploy smaller physical resources and off you go. You don't have to throw anything away. There is, of course, reduced cost in the infrastructure, again, because you don't have to throw things and bring things and so on. Refocus of IT resources, it's flexible, and you can create new businesses. Like right now, Amazon offers their infrastructure, their cloud infrastructure as a service. So as a small startup, I don't have to have any machines. I can open a startup having absolutely no machines other than just 1 or 2 laptops that we can use on a personal level, and that's it. Our data, our applications, anything that we do is hosted on the Amazon cloud. So what this will give me, it will give me great flexibility. So now my application as a startup, when I started my application, now I have 100 users. Good, that's good. So I need this amount of, so I know I need this amount of storage, I need this amount of speed and so on to be able to process the requests from 100 users. Everything has become a success, and now I have 1 million users. What do I need to do? Well, I submit a request to Amazon. Please expand the storage to this. Please expand the speed to this. Amazon gives me a cost structure. So now you have to pay this instead of this, and creates this virtual machine for me. And all of a sudden, I've become not like a small startup. I've become a huge company without having to buy any hardware resources. Go ahead.
So can we consider, for example, Dropbox as one of the clouds?
It is definitely a cloud. It is definitely one perfect example of whether Dropbox, Google Drive, OneDrive from Microsoft, all these are clouds. And these clouds, by the way, could somehow use, they could have no tangible resources. They can buy this from the Amazon cloud. They can buy this from anywhere. And they have a huge machine that they give it as a service to you. Okay? So this concept is beautiful in the sense that all the hardware now will become reusable. So we can connect millions of hardware and create a huge amount of infrastructure that we can use for all types of computing, whether storage, processing, hosting video, streaming, anything. And now even network is using this concept. So there's no more switches and routers in the traditional sense. Everything will be processed on the cloud somehow. But that requires some. So now we have the concept of software-defined networks. Our routers and switches will become dumb, would be dumb. They will not be intelligent. All the intelligence will be pushed to the cloud. Okay? So that's the real trend. If you want to plan your studies in the next 20 years, that's the direction. Okay? There are some technology trends as well which are becoming, which use the cloud computing in a way, as we can see here. So everything now is going to be pushed to the cloud. We don't use the term server anymore. Okay, the term server is disappearing. So now we always have a cloud. Okay, we don't have the concept of a hard drive. We always say cloud. Okay, so that facilitates some technology trends like smart home. Our homes need to be smart in the sense that we need to watch for our energy expenditure at home, the lights, the air conditioning, all the energy appliance in our houses need to be monitored and need to be efficient. Not only that, I can make some of the appliances at home smart in the sense of even my fridge needs to be smart. As we said, Internet of Things, everything will become a thing with an IP address, and this will allow us to add more intelligence to our appliances at home. So what is the benefit for us? The benefit is also huge. Because I can imagine yourself getting into the house and you see all of a sudden lights open with the intensity that you want. The TV opens because you have sat down on the couch. So the house will recognize somehow that you want to watch the TV. So all of a sudden the TV opens on the channel that you prefer. Okay. The fridge adjusts itself to the weather, whether it's now it's hot weather, so it goes up, now it's cold weather. So the house will become, all of a sudden you see the binders go away and you watch the sun and everything is around you acts to optimize your experience. Okay, so that requires intelligence in all the appliances and all the items in the house. Okay, so smart home is actually one of the technology trends that people are really focusing on. There is like billions of dollar industry for smart homes. Also, our energy expenditure at home will be should be very smart, in the sense that the light intensity needs to be controlled. Not only that, I need to have some solar cells maybe on top of the roof of the house, hopefully that can reduce the amount of energy expenditure on كهرباء. Okay, so I need to compromise the energy expenditure in my house in such a way that I can balance using reduced energy, but without affecting my my experience. I don't want to get into the room and the room is dark, so I need to have a balance. Of course, when I get outside the room, I need the lights to be off. Okay, so that's good. But when I get into the room, it needs to be on in the level that I want. So we need to have a balance between energy expenditure and the user experience. This is also one of the billions of dollars industry that's now being focused on worldwide, and especially here in Qatar and in the region. Okay.
But then everything should be connected to the internet.
Exactly. Anything would be connected to the internet. Okay. Powerline networking is also a trend. So powerline networking talk about the fact that our power lines at home, the power lines, I mean the outlets, which is like now 220 volts. Okay, we can use that for communication. Believe it or not, we can use that for communication, for communicating our information. If you think about it, it's similar to the concept of ADSL. So for ADSL, we use telephone lines, right? And telephone lines, they have certain level of voltage and things like this. So power lines talks about the fact that we can use our power lines for communication. What is the benefit of this? Well, in the past, we thought about ADSL because we already have telephone network in place. Well, we have power line network in place, right? So leveraging the existing networks to optimize the information exchange is a trend, is a general trend. So we need to use the existing networks for information because we already have telephone lines in place. Okay, so let's talk about standards that we can exchange information on top of the telephone lines. And they came up with ADSL. Okay, so now let's talk about exchanging information over power lines. Of course, this is more challenging because power lines, they use very high voltage. To be able to use information, digital information over power lines is rather tricky. But there is a standards now that allows you to use the power lines for communication. And now, inside our houses, we can have wireless routers to talk between the devices using wireless. And instead of because wireless has some limitations. So if you have multi-story house, if you have like 3-story house, you cannot have communication through the 3 stories using the same wireless router. So instead, you can connect your wireless router or you can connect any router to the power line, and all of a sudden you have communication upstairs and in the 3rd floor without having to do anything specific. Okay, so power line can be used at home to facilitate the communication with less limitation compared to other technologies. So that's another thing that's evolving nowadays and is becoming more and more widely available. Wireless broadband is also another type of service which will become, now it's not very common, but it will become very common, in which case we will not only have wireless routers at home, but you know the base station, the big base station towers? Okay, so we will have small devices in our houses that will connect directly to these towers. So in other words, we can almost get rid of our wireless routers because wireless routers, they use Wi-Fi. They use Wi-Fi technology. Whereas when we want to go outside, well, our cell phones can get to the tower, so they use different technology, not Wi-Fi. They use cellular technologies to get to the tower. So now, again, using the concept of converged networks, So why not have one small device in our house that makes all our house use the same technology, cellular networks. Get rid of Wi-Fi completely, or use it in a limited way, and have a small device at home that connects you directly to the base station towers.
But then the cost would be higher.
No, well, initially, if you want to preserve Wi-Fi, then you have Wi-Fi router and you have cellular router. Okay, then the cost will be higher. But if you, like throughout the time, we're supposed to get rid of Wi-Fi completely and use the same technology. Well, this is great in the sense that all your devices at home will use the same technology to get to the cellular towers. So your cell phone, your devices, everything will be using the same technology. So everything is seamless. Okay, and you don't need Wi-Fi, so you don't have to replicate anything. Well, in the beginning, maybe you have to, but later on, you don't have to use Wi-Fi. When this service becomes widely available, you don't have to use Wi-Fi altogether. And there is, of course, network security, which again is becoming very important in all domains. So again, it's important on the level of the information, storing information, encrypting the communication, and so on and so forth. So that's this chapter. So we talked about networks and the internet. We talked about the internet structure. We talked about the different sizes of the network, whether small size LANs and big size WANs, and the internet as the largest form of network infrastructure. We talked about the different features that need to be supported in the network, whether fault tolerance or scalability and security and so on. So this is an overview. So the Cisco material is somehow, it gives you the whole picture in the beginning, but the picture will be very hazy, very blurry. Okay? Then in chapter 2, you will see that part of this picture will become clearer and clearer. And then in chapter 3, you see another part of the picture. But now we have covered the whole picture. So again, if some of these concepts you did not really absorb really well, don't panic, it's fine, because we have to go through all these things again in greater details. Okay?